Hi, my name is Chris Gagliardi, and today I'm going to be talking to you about the talk test. My presentation today is based off an expert interview I conducted with Dr. John Percari. Dr. John Percari is he is the program director for the Clinical Exercise Physiology program at the University of Wisconsin-La Crosse. He teaches courses in exercise testing and prescription, cardiovascular physiology, and electrocardiography. He has also conducted over 450 research projects over the past 25 years and has authored and co-authored over 175 research articles. And basically the research that I looked at on the use of the talk test for exercise program design, specifically looking at programming for exercise intensity. He's been involved in a lot of the research, the most recent research that I could find, and I was lucky enough to have an interview with him over the phone. To give some background on the talk test, some of you may already be familiar with the talk test, but basically with the talk test, this goes back to 1937 with a Dr. John Grayson, who would give this advice to mountaineers that would be climbing. And essentially what he would tell them is to climb no faster than you can speak. And that advice he was giving people, that recommendation that he was giving these mountaineers, is related to the talk test. So the talk test wasn't necessarily used or invented or being incorporated back then. But Dr. Grayson, what he realized is that when people would climb or exercise or increase their intensity to a level where they could no longer speak comfortably or they could not speak at all, they were working at an intensity that they could not maintain for a long period of time. So when you think about an event like mountain climbing, for example, where you have to be able to sustain a level of intensity over a long period of time, multiple days even, it's really important that you're working at an intensity that you can maintain for as long as possible. And he realized that when you were climbing at a pace where you were still able to talk, that was an intensity that you can maintain for a long period of time. So it's really like the highest exercise intensity at which you could still speak, and him kind of describing that as being the right intensity, for people to exercise that they can maintain for a long time. And that's really what sparked my interest in the talk test, was kind of looking at, well, where did it come from? How is it used now? Because it's a different approach than other approaches I had learned throughout my initial schooling when I worked on getting my bachelor's degree. So it really piqued my interest. So really one of the first questions that I asked Dr. Percari was kind of what is the talk test? And in my conversation with him, he really described this ventilatory response to exercise and what's occurring. So if you look at the image that I included on this slide, it's really just depicting something I think we all know or would agree upon, that as exercise intensity increases, our breathing increases, right? Our breathing rate, or the amount of air we're taking in, and the frequency at which we're breathing increases. So really this use of the talk test is based on this fact that we know this, and that we know that the volume of air going in and out of the lungs increases linearly or similarly as exercise intensity increases. And if you look at my image here, you can see that it's not a purely linear relationship. There are these deflection points, right, where the relationship doesn't match up exactly, and they're labeled VT1, or the first ventilatory threshold, and VT2, the second ventilatory threshold. And what Dr. Percari was describing to me is that when you're working below VT1, the challenges, and this is that level where you're able to speak, that that the advice that was given to those mountaineers was to work at that intensity where you are able to speak. Excuse me. So that would be that below that VT1, where it is this linear relationship. And basically what's happening is that the cardiorespiratory challenge when you're below VT1 does lie within respiration itself, or inspiration. So can we take in enough air to meet the demands of the exercise intensity at that time? Once we cross that VT1, our intensity increases such that our heart rate is increased and we move above that first ventilatory threshold. Then the cardiorespiratory challenge changes, and we go from the challenge being with inspiration to really the challenge coming with moving to expiration. We need to blow off the CO2 that's within our body, and that's really the driving force that's kind of driving our ventilation at that point. And so initially the need for oxygen is met through an increase in tidal volume, or purely the amount of air that's moved with each breath. So we're taking deeper breaths initially. We take deeper breaths to take in more oxygen. And then once we hit that VT1, when we get to that point, then ventilation starts to increase non-linearly. That's where we see that VT1, that first deflection point. And then again, that happens again when you reach VT2, which would be greater intensity, as you can see, and then ventilation, hyperventilation occurring. And at that point, it's to blow off the excess CO2 that we need to get out of our system. Interestingly, also, Dr. Percari mentioned that at VT1, and this is based off the respiratory exchange ratio, that when you're below VT1, you're primarily using fat as a fuel source. So a greater percentage of the fuel you're using is coming from fat. And then once you cross VT1, a greater percentage of the calories you're using to fuel the activity that you're doing is going to come from carbohydrates. Now, the VT1, other names for that first ventilatory threshold, and maybe some more common ones that you may have heard of, are that it's also called the anaerobic threshold, because it's the first point at which lactate begins to accumulate in the blood. And again, at that point, once you hit that point, your ventilation gets driven by your need to blow off CO2, not necessarily to bring in more oxygen. When you VT2, then you have the lactic acid building up in your blood, in your system, at a greater rate at VO2, and hyperventilation begins to occur. Your breathing frequency increases, and the ability to blow off the CO2 is no longer adequate to buffer the increase in acidity. And at that point as well, the intensity is such that you can't maintain it for a long period of time. You're working so hard, you can only maintain that for short periods of time. And that VT2, that second ventilatory threshold, is also known as the respiratory compensation threshold and the onset of blood lactate accumulation. So even though it kind of starts to build up at VT1, we're able to buffer it out of our system. But once we hit VT2, it begins to accumulate within the blood. An analogy given for what's occurring with regard to the blood lactate as the exercise intensity increases was given to me. And this analogy really just states that when you're, if you think about rowing a boat, so I'm rowing a boat and my boat has a small hole in it, right? So, and let's say I'm rowing, no water's coming in that small hole when I'm below VT1, and that the water coming into the boat is the lactic acid. You can think of it this way. So I'm rowing my boat, I'm below VT1, no water's coming in my boat. I got a small hole in my boat, some water starts to come in. Now, it's not enough water to overwhelm my boat, or not enough lactic acid to overwhelm my system. And I'm able to buffer it out. Like I could bail it out of the boat. It's not really doing any harm at that point. It's kind of, it's annoying while I'm rowing my boat. I got to buffer the water out, but it's not going to sink me. It's not going to, end my little trip I'm going on. So I can buffer it out. Now, if I keep rowing, let's say that hole gets bigger and I reach VT2. And now that hole gets bigger, more lactate is coming in, more water is coming in, and it's coming in at such a rate that no matter how hard I'm trying to bail out the water or the lactate, I no longer can. So it's overwhelming my system, and it's coming in at such a rate that I can no longer get the lactic acid out. So it starts to overwhelm the system. So that's kind of what's occurring with regard to ventilation and blood lactate. So now just to really put this together is looking at how this relates to intensity. So ask the question is why is the talk test effective? And really what we talked about was this 3-zone intensity training model, where we looked at using the ventilatory thresholds as a way to determine how intense someone is exercising. And for zone 1, this would be considered low to moderate exercise, and it really reflects heart rates below VT1, and someone could talk comfortably. When we look at zone 2, this is moderate to vigorous exercise, and it reflects heart rates from VT1 to just below VT2. And Dr. Bakary made it clear that there's, it's not like it's a huge difference in heart rates between VT1 and VT2. It's really a small range, but so that moderate to vigorous exercise in zone 2 represents a small range of your heart rate. And then in zone 3, this would be vigorous to very vigorous exercise, and it reflects heart rates at or above VT2, and you definitely cannot talk at that point. You can maybe get a word out at a time, but you have to it'd be interrupted by your breathing and your need to blow off that CO2 that's in your system. So if you think about it this way, below VT1, I can talk comfortably. And then VT2, you're kind of not sure if you can talk comfortably. Talking becomes more challenging. And then when you cross over VT2, you definitely cannot talk comfortably. And this can be really useful as a way to help people gauge how intense they're exercising, how hard they're working. And even as recently as many of you may be aware that the physical activity guidelines were recently updated. So there's now the 2018 physical activity guidelines, and they actually reference the talk test as a way for the community to gauge their intensity, because it's kind of an easy recommendation that you can give if someone's like, oh, well, you're telling me I have to do, or I should be doing 150 minutes of moderate intensity physical activity, each week. What does that mean? What is moderate intensity? So they gave this recommendation or suggest using the talk test. So they say you're doing moderate intensity aerobic activity if you can talk but not sing. So if you're working out at a level where you could sing, then you're not working hard enough. But if you're working so hard that you can't talk, then you're working too hard. You're above that moderate intensity. So if you're looking for that moderate intensity range, looking for an intensity where you can still breathe well enough where you could talk but not sing. All right, so basically I asked Dr. Bakary too, really what makes the talk test so simple to use, and kind of just looking at the images that I put on these slides here, is that there are other methods where you could determine exercise intensity and how hard clients should be working. Some of them require, the use of lab equipment, actually collecting oxygen, which there's a time and there's a place for those things. And then my other image where you see the individuals that kind of look like they're talking and exercising at the same time. Giving these simple recommendations could really be easy for people to use, where they could really say, okay, well, if we're exercising at the right intensity, because we want to be in that moderate range, we should be able to carry on a conversation while we're talking. Not that we necessarily have to be talking the whole time, but we know if we can carry on that conversation, we're at the right pace that we should be going at. Now, if we're going too hard and we get to a point where we can no longer talk comfortably, then we can back off a little and get right into that sweet spot for where we want to train. So it's really this unique method of determining exercise intensity, and it's individualized to the person, because for each person, that point at which talking becomes uncomfortable is going to be different. It's going to be based on our unique physiology and the intensity that we're working at. So, really just to sum up kind of the things I learned during this interview that I found interesting. One, like I just mentioned, about how individualized this method is and how simple it can be to use, where you're literally looking at, because we know about these ventilatory responses that occur as exercise intensity increases, we can use that to gauge how intense someone is exercising. And some notes or takeaways from my interview was that when you're below, just how does this all tie together with all the different methods of monitoring exercise intensity, and thinking about how does it relate to RPE, so ratings of perceived exertion. And really what Dr. Picari explained was that when you're, from his research, when you're exercising below VT1, that equals about an RPE of 3 to 4 when you're using the 0 to 10 scale, and of moderate to somewhat strong, or an RPE of 13 on the 6 to 20 scale, or somewhat hard. Also, one thing I learned was that in exercise intensity just below VT2 represents the highest sustainable intensity for an individual. So that's the highest level, just below VT2. It kind of shared that some elite level athletes, they will figure out what their heart rate is at VT2. So when I reach that point where I can no longer speak comfortably, what is my actual heart rate? And in competition, in their training, they will train like 1 to 2 heartbeats below that VT2 marker, because that's the highest intensity they can sustain for a long period of time, which I thought was interesting. The other thing was that learning that the need to get CO2 out of our system is the greatest stimulus for ventilation. So not the need to take in more oxygen, but the need to actually get the CO2 out is the greatest driver for ventilation. And then also that I always imagine that range of heart rates between VT1 and VT2 to be significant, and he explained it's not really that significant. It's a small range, a small difference that you're looking at. And then also that the talk test can be appropriate for all individuals to use, so it's not like it only works with a certain population, and it could just be kind of easy, sort of user friendly, and can be a great way to help people gauge their intensity. My last slide is just going over the references that I use when putting together this presentation and when coming up with my questions to go over with Dr. Picari. And I'd really like to thank Dr. Picari for letting me have the time to interview him. And I hope you all enjoyed this presentation and are excited to maybe learn more and try using the talk test if it's not something that you're currently used, to help clients determine their exercise intensity. Thank you.